anytime it is a transition metal, you're going to have Roman numerals. If it is not a transition metal, you don't need to worry about your Roman numerals. Now, second thing we have to look at is how do you know the difference between when it's going to be... So we looked here at what's going on with our electrons, right? And this always happens. The electrons are transferred from an ionic, so from the metal to the non-metal. What happens when we have two nonmetals? So for instance, if I have fluorine, which has 1, 2, 3, 4, 5, 6, 7 electrons, and it's going to bond with another fluorine, okay? These guys are actually going to share their electrons. Nobody's giving any electrons away. So what you end up with is compound looks like this. So we have 8 electrons here, and you have 8 electrons here, okay? Which is different than something like Na, which has 1, fluorine again, which has 7, right? Because this is a metal, metals always want to do what? They want to give away their electrons. So this electron is going to come here. So in this case, you get Na plus F, 1, 2, 3, 4, 5, 6, 7, 8, 1 minus. Okay? So you see the difference between those when we talk about our Lewis dot structures? So now when we go to name these, okay? So if I'm looking at naming this, we have boron, okay? So here's boron, okay? So in this case, boron is boron a metal? It's not, is it, Mr. Carter? I can't remember. Boron is not a metal. No. It's a metal lead. Okay. So in this case, we're going to name this. This is a non-metal bond. So that means we're going to name it as a covalent compound, right? So this would be boron. Now, we see 3 here. This 3, remember in ionic naming, we cross this. But with covalent, this 3 belongs to this bromine. So this is going to be boron tribromide. Ending we still change to IDE, right? But this 3 is basically describing how many bromines we have, okay? Now, we go to the next one. Calcium is a metal. SO4 is a non-metal. So we have calcium. And then SO4, remember, this is on the back side of your periodic table. SO4 is sulfate. So this is a 2+ and this is a 2-. Where did I get those numbers? This is a group 2 metal. So it's going to have a positive 2 charge. SO4, it tells us on the back of our chart. So these are going to cancel out, right? And so we're going to get calcium sulfate. Carbon, bromine, both are nonmetals. This is a covalent compound. Sorry, did I say calcium? Copper? No. Crap, carbon. Okay. So this is, how many carbons are there? There are 2. So this is dicarbon hexabromide. Okay? And if you guys recall, when we name covalent, right? Compounds. We're going to use the prefixes mono, which is 1, di, 2, tri, 3, tetra, 4, penta, it's 5. Okay, what's after penta? Hexa, 6, hepta, 7, octa, 8, nona, 9, and deca, 10. Okay? So those are all the prefixes. Now, the only time we don't use mono is when you have something like this. If we have NO2, if it's the first one, we don't use it. Okay? A good example of this is carbon dioxide. This is one single carbon, but we call this carbon and then, carbon dioxide. Okay? Or if you have CO, this is carbon monoxide. We don't call this monocarbon monoxide, okay? We don't do that. If it's the first one and it's by itself, you don't put mono in front of it. So, let's go back over here and look at these. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, let's see, this one is V, vanadium. It is a transition metal, so we see vanadium is right there. This is a tricky one. This 2 came from up here, right? Which means there was a 1 there. However, so this would be V2 plus and O 1 minus. We know that oxygen is always a -2. So this is actually a 2 here, and this had to have been a 4. Because remember, with ionic compounds we can reduce. We don't reduce with covalent ones, but ionic compounds we can. So this would be vanadium 4 oxide. Next one, carbon. And again, this is non-metal. Carbon tetra, right? Hydride. And the last one here we have, again, is a non-metal. So this is a covalent compound. And so this is going to be nitrogen, dinitrogen, sorry, 2 nitrogens and 3 oxygens, trioxide. Alright, so if we go to this naming over here, we have tetra, tri. Automatically that tells me that this is a covalent compound, right? So tetraphosphorus, so I'm going to have 4 of these, 4 phosphorus, right? And triselenide, so Se3. Now, I don't see any dyes or tris or any of that, so this tells me right here that this compound is ionic. Being ionic, I need to look at this. So I have potassium. I know potassium. Now I got to worry about oxidation numbers. This is a +1, and I know that because potassium is in group 1. Acetate ends in ATE, so I go to the back of my chart, and can you see this? I find, where's acetate? Acetate, first one up here, okay? It has a -1 charge. So I'm going to say this is C, what is it, 2H3O2. This is a 1 minus. Remember, we cross these, and I'm going to get K, C2H3O2. Next one, iron 2. This 2 right here automatically tells me that this is a transition metal, and the fact that it's got a Roman numeral tells me it's an ionic compound. So this is going to be Fe2 plus. Phosphide ends in IDE. It's phosphorus, right? Phosphorus is in group 15, so it is a -3, so it's 3 minus. Cross these, and I'm going to get, ooh, crap, Fe3P2. Okay? Next one, disilicon, hexabromide. Di goes with silicon. This is a covalent compound, right? So this is going to be Si2Br6. Okay? Alright, so this gives you a good gist of how you're supposed to do the naming. Let's look at some of the problems that were on our test that you guys just took. Do you have the test? That's fine, the one that's there. Okay. This is A and B, right? 7A and B. Alright. Okay. The only other thing I didn't name was acids. Let me name these real quick for you, some acids. Okay. When we're naming acids, alright, anything that starts with an H, okay, that's going to be an acid. So if it's HCl, we say it's hydro, blank, ic, acid. So in this case, it would be hydro, chlorine, we change it to ic, right? So we change the ide to ic, so it would be hydrochloric chloric acid. If you have one with a polyatomic ion, like H2SO4, again, I know this is an acid because it starts with H. So in this case, you're going to change the ending, so this is sulfate. We change this ending here to ic acid. So this would be sulfuric acid. Okay, so 8 goes to ic, ide goes to hydroic, and if we have ite, so let's say we have HNO2, this right here is nitrite. Starts with an H, so it's an acid, so this is going to be nitrous, the ite goes to us, nitrous acid. Okay? And for your purposes right now, which we'll change this in a little bit, but if you see something like this, and it ends in an OH. Okay, this is hydroxide, and this is a base. Okay, all right. So, first question. It reads, let me see if I can get this a little bit closer. Okay. The correct name for aqueous solution of HCl. Okay, so we just talked about this. Starts with H, so you automatically know it's an acid. So which ones can we cross out? Well, we can cross out this one. Okay? Then we talked about the fact that it's just chlorine, so it's a single atom. We need to look on the periodic table, and we know that that is chloride. Ide goes to ic. We can cross out this one. Ide goes to ic, and since it's not a polyatomic, we have to put hydro in the first part of the name. Your answer choice here was